Okay, shall I get going then?
Yes.
Great. Well, thank you so much, everybody, for joining today. And welcome to this CCAI webinar series, where we're going to be looking at how international organizations are using some forms of machine learning in the response to climate change. So a huge thanks to our three speakers, Ashley Popel, Edward Anderson, and Mercedes Taraverdi, who are joining us from organizations representing the UN and the World Bank, to give us a look at their work in different areas in which they're using machine learning in international organizations in different aspects relating to climate change. And I'm Catherine, I'm a member of CCI, and I'll be moderating today. So if you have any questions, the way this will work is we'll have 3 lightning talks by these 3 excellent individuals. And if anyone has any questions going through, feel free to type them in the Zoom Q&A bar or online in the YouTube version as well. And we'll try and then answer them with 15 minutes Q&A at the end. Great, so handing the floor over to Ashley, who will be the first speaker. Over to you, Ashley, to share your screen.
Brilliant, thank you, Catherine. Can you see my screen okay?
Yes, I can see it.
Fantastic, thank you. So good morning, good afternoon, everyone, depending on where you are in the world. My name is Ashley Popel, and I'm actually an economist by training. I just finished my PhD in economics at the University of Oxford, and I've been working closely with the Centre for Disaster Protection, a think tank in London, who has also been working very closely with the UN OCHA, which is the Office for the Coordination of Humanitarian Affairs. So today I will be speaking about the topic of the importance of timeliness and effective targeting in climate disaster response, building on research that I've been doing with other researchers at the University of Oxford, as well as kind of showcasing some of the very cool policy innovations that these other organizations are doing. So just to motivate where we're coming from. So climate disasters are becoming more frequent, more intense, and especially already affecting low and middle income countries. In the backdrop of all of this, there's a lot of aid that goes in the form of development assistance, but also a huge amount in the form of humanitarian aid, of which about a third is being spent on natural disasters. The rest is largely spent on conflict. And given that we know that climate disasters have large long-run welfare implications that can be appearing even decades later, the question is, how do we best respond? The traditional approach tends to be late, it's politicized, it's insufficient. Typically what happens is there's a crisis and then there's a funding appeal. And so given that climate disasters tend to be largely predictable, it does beg the question of whether we can design systems that are faster, more reliable, and better targeted. And just to be clear, in the humanitarian sector, a new approach that's being tested out is what we call anticipatory action, whereas in the development sector, the types of terms that are often used are shock responsive social protection, but often refer to similar things. So just as a roadmap for today, I'm going to provide a very brief overview of a new policy innovation that is forecast-based due to the emergence of really cool data and technologies. We are now able to respond in ways that we haven't been able to do in the past. And from this, I'll showcase an example that highlights the importance of timeliness, being better targeted, which then provides potential for the role of machine learning in particular. So what is this policy innovation? As I mentioned before, in the humanitarian sector, the traditional response is the following. So there's usually a shock or event that happens. And as the needs, this kind of graph can showcase humanitarian needs, as the need builds, the response begins. So typically there's a needs assessment, which then mobilizes fundraising and an action plan. And then after a lot of delay, there's finally an intervention, which then dissipates the need over time. But by this stage, it's already quite late. So an alternative approach using data that we can acquire beforehand would be to actually forecast or predict whether a climate shock is about to happen. And so the idea here is we can use the probability models and assess the risk of a climate shock occurring. And this is the ability to do this accurately depends a bit on the shock. It's particularly accurate in flood forecasting. And the idea is we can pre-position a bunch of tools such as an action plan, pre-positioning financing, and forecasting triggers such that when the data reaches a particular threshold and a trigger is activated, humanitarian aid is provided immediately. And this happens before the shock even occurs. And as you can see, the idea is that this is expected to reduce the level of humanitarian need. The UN OCHA, with whom we've been working with quite closely over time, are piloting this anticipatory action approach in many different countries, as you can see here, for many different types of disasters, ranging from drought to flood to cholera. And the idea is to be able to use these pilots to showcase whether we could have a systems change in the humanitarian world. But it's also true of social protection, and the World Bank have been doing some really cool work on this too. The big question here is, in order for this response to be effective, it needs to be timely and it needs to be well targeted. And these are two things that the jury's still out as to how to best achieve these two objectives. And so I'm going to first showcase an example of an intervention that one of these anticipatory action pilots that OCHA was coordinating last year in Bangladesh. And we, a group of researchers at the Centre for Disaster Protection in Oxford, conducted impact evaluation to showcase that giving cash to people before one of the worst floods in decades in Bangladesh was more effective in improving people's well-being even months later. So how does this model work? Well, basically there's, as I mentioned before, there's pre-positioned financing. So that's been agreed beforehand. There's an action plan. So here, in this case, there's a set of UN agencies that have predetermined what they would do in anticipation of a shock. So we're working with the World Food Programme, who gave cash transfers over mobile money. And there's a set of forecasts and triggers. And this graph here shows the predicted water flow, which is the dotted line, and the observed water levels ex post. And you can see that our predictions are really good, especially in floods. The jury is out on droughts, given that it's a slow onset disaster. And there were two triggers that were designed that had a 10-day lead up versus a 5-day lead up, which activated the interventions. And after the 5-day lead up activation was activated, funding was released within 4 hours, which is unheard of in a humanitarian world, which then reached approximately 23,000 households over 5 days. As you can see, the humanitarian response plan, which is the traditional approach, was only released, let alone actually acted upon, on the 4th of August, which was a whole month later than the first trigger, which had been activated on the 4th of July. We evaluated this, the anticipatory cash transfers that were provided in anticipation of shock, and we showed that even 3 months later, which is when we were able to collect the data, those who received cash relative to those who did not had better welfare outcomes. In particular, they were less likely to go without food during the flood itself. It's about 36%, less likely to go a day without eating at all. They were more likely to evacuate and protect livestock. And as a result, 3 months later, they had higher consumption, both adult and child, which has, as we know, has long-lasting implications for child development and learning. And they're also less likely to borrow and recover better, more quickly. We also found that speed mattered. So receiving the cash transfer 1 day earlier relative to the flood peak resulted in higher consumption even 3 months later. So, and all of these results were measured before a traditional response would typically arise, especially, so for example, comparing to 2019 when the traditional response arrived 100 days after the flood peak. But so there's clearly a need to act more timely, and given the amount of data out there, we can really be innovative about how we predict climate disasters and respond to them. Conditional and pre-positioning a whole bunch of infrastructure. But there's a bit of a tension between having a timely response and better targeting. And by better targeting, I mean, can we identify those households who are most at risk of needing assistance later on? So as you can understand, the further out you are from the climate disaster striking, so the earlier you are, the harder it is to predict who would actually be most impacted. This is not an unusual problem. I mean, even in typical in traditional social protection systems, there is typically low coverage and lots of people are falling through the cracks despite having high needs. And it's time consuming and expensive to go out and create these registries of people. So the question here is, if we want to have an earlier response, can we use machine learning based targeting to identify people at need in real time and at scale before a crisis hits? So I'm just going to showcase a very cool paper that's by no means my own. It's a bunch of other academics, Aiken et al., who have this MBR paper out, who are working very closely with Give Directly and the government of Togo. And what these guys did is they worked with the government of Togo, who have a social protection program, to deliver cash. And they brought in machine learning through what they called the mobile aid approach to be able to target people in anticipation of a COVID lockdown. And what they did is a two-tiered kind of geographic targeting approach. So the first is identifying geographies that are impoverished in the rural areas needing support. And then the second is within those geographies, can you identify which households should be given the cash transfer? And so they collected traditional survey-based measures of consumption and wealth, which they then used to train algorithms to recognize poverty. So kind of building out these poverty maps, which was then used to rank which cantons they should be prioritizing. And so that was the first step. And then the second step was to use mobile call data, which includes calls and SMSs, to predict which individuals are impoverished and thus in need. So this is kind of the three-step approach they took. The first step is the one I just described. So predicting the poorest geographies using satellite imagery and developing poverty maps. And then the second approach is using call data to predict the poorest people within those geographies. And that was used to whitelist cell phone numbers. And then there's a second and third step, which was to invite households to apply for the funding and then automatically transferring funds through a mobile money account. So in my last 2 minutes, I just want to highlight two potential opportunities here. So these are very early stage research projects that we're looking to develop. The idea is, can we take this mobile aid approach, which I've just described, and apply it to a climate disaster response? So what we'd like to do is develop impact-based predictions of flood exposure. So taking the Bangladesh case study and saying, instead of just using pre-existing registries, which is what WFP did, can we use this mobile aid approach to identify which households have baseline vulnerability, and then which households are also, or which geographic areas, have kind of the baseline vulnerability to floods, and also are most likely to be impacted by a given shock in a given year. And then within those geographies, can we then target households who need support? The second approach, the second application is to actually take this to social protection systems. So, for example, the Productive Safety Net program in Ethiopia targets the chronic poor. And so far, machine learning has been used to estimate poverty at the administrative level. And this is done by combining surveys with remote sensing data, because surveys are often conducted at a much higher level than the admin levels being used to target. The question is, can we go further than this? Can we develop a predictive dynamic model of poverty that is shock responsive to droughts? So combining, for example, high frequency phone surveys with remote sensing data to be able to create these dynamic poverty maps, which could then guide where the PSNP goes and targets households. So to conclude, machine learning-based targeting could be used as a first step to improve the impact of these shock responsive social protections. There is a challenge in this, in that there's a lot of effort that needs to go into preparing for this. There's a lot of infrastructure that needs to be put in place before these can work. And importantly, these approaches should be integrated within existing structures rather than operating in parallel. And there's a lot of open questions. It's not evident that this is necessarily the most optimal approach going forward. And so there's a lot of research that could be done trying to explore, for example, exclusion errors, who is being excluded, who is being included, etc. These research projects I've just outlined are super early stage. So if anyone's interested in sharing insights or being involved, please do reach out. Thank you so much.
Okay, thank you so much, Ashley, for a fascinating presentation and lots of really important and very thoughtful responses to big, important questions. And there were quite a few questions from the audience, which we'll deal with later if everybody doesn't mind. So next, moving on to Edward's presentation. So Edward Anderson is a senior technology and resilience specialist at the World Bank, based in Dar es Salaam, and he's going to tell us about some of his work with the World Bank in Tanzania. So over to you, Edward. Thank you.
There we go. Thank you very much, Catherine. Sorry for the delay. And thanks for the invitation to speak. I hope you can see the presentation full screen.
Yeah, we can see it. It's fine.
Great.
Thanks.
So as my title suggests, I work specifically on disaster risk management, and I'm speaking actually from Tanzania. So I'm going to cover some examples of machine learning in the risk evaluation space, particularly as it applies to projects we've done in Africa and Central America. But I do want to acknowledge before I begin that there is quite a broad spectrum of digital services in climate risk management. And as Ashley was talking about, predicting shocks, safety nets, and identifying the vulnerable, I see huge potential in areas like education, awareness, gamification, behavior change, social media, coordination, and communication. So I'm speaking primarily from the sort of techno-scientific disciplines of flood risk modeling, landslide risk assessment, hurricane damage assessments, which is bread and butter for the Global Facility for Disaster Reduction and Recovery, where I'm now based. And I think a key challenge for us in low-income countries, particularly fast-growing countries, is summed up in this picture where you see actually the city center of Dar es Salaam. And it's this sort of concatenated set of problems as a result of informality and unplanned growth. You have buildings in the floodplain, you have dilapidated or inadequate drainage infrastructure, you have a lack of solid waste collection, which can compound flood dynamics, it can exacerbate waterborne disease, you have environmental degradation and deforestation in the peri-urban areas, also leading to sedimentation of waterways, all of which compounds upon itself. And with variable climate, we're really dealing with increasing complexities that are really hard to address with traditional models, sort of an expert-centric engineering or scientific approach to flood modeling in a fast-changing environment is very data hungry. And oftentimes we don't have data, or it's missing, or it's inaccessible, at least in the traditional approaches to how we do these sort of expert-driven models. So for my mind, the machine learning potential is really large, and it builds on top of this data revolution we're living in terms of alternative sources from drones, satellite, mobile phone data, social media data. The whole big data ecosystem, I think, is now leading us to sort of think differently. How do we use these new data sets to get faster, better, cheaper, and less complex analysis of how the world is changing? I mean, at the end of the day, it's really about how do we manage what we're not measuring? And can we find classifiers and tools that help us understand that change in a way that's actionable? So I'll give 3 examples. I'll start with the first one I was involved in a bit more detail, and I'll just touch on a couple others. So my first direct experience of sort of getting into machine learning was a drone survey of the housing stock of Zanzibar. The Commission for Land was very concerned about rapid undeveloped sort of urban growth across the two main islands of Zanzibar and the Indian Ocean, 1.6 million people. Their building register had 160,000 buildings in it. And by the time we completed the survey, we had counted over 500,000 buildings. But the nature of many of the buildings, as you can see from the photo, is that people tend to sort of secure a plot of land by building a foundation, and then may leave it idle for 10 years or so until they get the money to put on a roof and really start construction before they then move in and inhabit that dwelling. So it was really a challenge of identifying what is the nature of the urbanization, where is the future urban growth going to be, so they could develop better risk assessments, town plans, land use, and titling, and address that. So what you see with the drone image that's great is it allows you to not only identify buildings, but really classify the kind of structure. You can tell quite easily if this is purely a foundation and otherwise uninhabited, or if someone has started construction, or if the building is actually already being lived in. And this is something that we can get from 7-centimeter imagery from the drone that we wouldn't really be able to do from a satellite image, at least not easily. And so the step process was to process the images, digitize the buildings, and then label the building. And we did this with humans, mostly Zanzibari students, and here's a picture of some of them, but also surveyors from the Commission for Lands. And this happened in 2017 and 18, but it allowed us to collect a massive amount of data to then engage for free to us in a partnership with We Robotics and Coda Lab to run our first AI challenge, seeking kind of open source algorithms that could automate the process of both building segmentation and classification that was trained on African dwellings that had these characteristics of the rusted sort of corrugated iron roofs that you see. So that happened in late 2018, and we were able to provide 100 square kilometers worth of imagery and the associated building segmentation and labels, and then run 25 teams, I think, were shortlisted that ran their algorithms with that data, and we tested it on another 63 kilometers of other parts of Zanzibar for which we had already done the human processing. And it really was a sort of two-step algorithm. It was, as I mentioned, segmentation and looking at the accuracy of building counts in the polygon, and then classification and trying to then compare the algorithm to the human. And this led us into sort of a number of new domains in terms of discussion with government. But our main conclusion was that indeed, in terms of just segmenting medium and large buildings, the AI is superhuman. It can do it very quickly, very accurately. It did struggle with very densely packed small buildings where a human could actually tell quite easily if it's a collection of little outhouses jammed together rather than a very strangely shaped medium or large house. And then we got into this new terminology of Jacquard scores and confusion matrices and how to sort of relate sort of quality assurance terms to the Ministry of Lands. I think is part of the challenge and then the sort of the new frontier of machine learning, as it were, in development. So being able to define a limit for fitness of use, especially as compared to humans who were themselves disagreeing between each other sometimes, if a building was a building under construction or not. So that one was not quite as clear cut as a completed building or a foundation. And certainly we thought that 100 square kilometers of data was a lot, but we did find that with more data, you get more accuracy. So these were just sort of the step-by-step process, but for us, this was an experiment. We ran it almost as a byproduct of the mapping campaign. We didn't use those AI segmentations in the public program, but the winning algorithm was then used in St. Lucia, the Caribbean, and in Guatemala by a different team that was informing development interventions. So this is an example from both Guatemala and St. Lucia that combined both drone imagery and street view imagery with the purpose of trying to quantify the vulnerability of buildings, both to landslides, earthquakes, and hurricanes. And in Guatemala in particular, it's looking at what they call the soft story, where often you have a single story shop with a large shop front that is built, and as shop owners gain income, they build a floor above and maybe a second floor, and it compromises the structural integrity of the building. And it's a real concern in many places in Guatemala. And sort of target for a retrofitting campaign. But the question is, how do you dimension that? Where are the structures of concern? What's the cost going to be? So the main application was really to look at new construction, how many floors have been added, and identify which buildings we think have this soft story ground floor based on the sort of width of the shop window opening and the retaining walls. So in the case of Guatemala, you get an estimate of the distribution of those structures. In the case of St. Lucia, it was more looking at the roof types and building floors to look at the predicted hurricane damage that may result, again, to inform a retrofitting campaign for addressing those vulnerabilities. And then the third sort of quick example I'll give is something we started during the pandemic in Freetown, Sierra Leone, but is still ongoing in several other countries now, actually, which is the sort of automation of urban tree canopy and green urban services in cities that we're very interested in. And in the case of Freetown, the city suffers from devastating landslides contributed to by deforestation. And so a big commitment of the city has been to plant 1 million trees and see them succeed, so track those trees by the end of next year. And so what we did is partnered with human data collection on the ground and a firm called Green Stand using mobile apps, an open data kit to tag the trees that are being planted, but also sitting digital tasks to digitize from satellite images, the tree canopy, and train an algorithm to monitor changes in that canopy. So we can ideally have indicators for the extent of green urban cover within the city, as well as track the individual trees that have been planted. Now, these are sort of 3 fairly similar urban ecology use cases. What I also wanted to plug was a concern that I've found in my experience and also has been summarized in this document that I did not write, but my colleagues in my new unit at the Global Facility for Disaster Reduction and Recovery published in April of this year on responsible uses of AI in disaster risk management. And they highlight 4 kind of key sort of project level concerns: the various sources of bias that can be introduced unwittingly through any system of this kind, the challenges in how you explain transparently why the model predicts what it does, and convince your counterparts in government that this can be trusted or not. How would you address privacy and security concerns, especially personally identifiable information and the sharing of very high resolution data or very granular data, which are available, but in combination can compromise privacy. And really sort of trying not to get carried away by the hype sometimes, especially when projects get politicized, ministers become, or mayors really love what's going on. Sometimes being innovative becomes the mission, and there can be a slippery slope there as well. And I've added to this, I think, at a sort of more outcomes level, a need to sort of think about inclusive opportunities for digital communities and target beneficiary groups. And how do we ensure that we are developing tools that will scale and be sustainable at scale? So these are really sort of our preoccupations. I think my team and I don't really see ourselves, we have some data scientists on board, but we really see ourselves as the counterpart to the data science team, where we're really looking for opportunities to include local data collectors in the training data sets, in the validation and ground truthing. So we've been playing with microtasking platforms and involving or trying to create this positive digital feedback loop between a global algorithm development and these local data contributions, whether it's a field-based task or a sitting digital task, to try and maximize that contact and really co-create the algorithm together. So this is an example we ran late last year during the pandemic. We couldn't get experts in to assess informal settlements. We started working with German aerospace agencies, enhanced 3D version of the World Settlement Footprint, which is a digital layer that tracks building change globally, based on their own machine learning approach to various satellite hyperspectral data sources, radar, infrared, and optical. But it requires quite a large degree of validation. So 1.3 million ground truth points we collected through a partnership with Google Tiny Tasks. And in this particular example, we then also used street view imagery through a platform called Mind Earth to validate building characteristics, including number of heights. And we did it by sourcing the data from citizens of the target communities we were really trying to characterize. So in this case, Tanzania and Kenya. So this is sort of the product. It's a global product, but we wanted to see how accurate it would be. And we really wanted to use it in COVID modeling in informal settlements in Africa. So we focused on validating it in places like Nairobi. So this is what it looks like in Nairobi. And it's an example of what we sort of think of as a co-created algorithm for building change and floor area ratio change over time. So final sort of thoughts on going forward. My new job now is to set up a team and a program called the Digital Earth Partnership. And so we are still getting going, but it's leveraging a partnership with the European Space Agency and new Earth observation data sources, including drones. And then the new classification tools, particularly the machine learning suite of different approaches. And we're not, as I say, sort of the technology experts per se, but we see ourselves as the capacity building, skills transfer, and custodians of sort of inclusive opportunity approaches. So we do have these principles for design that I think try to put at the heart of it this do no harm principle and promote ethical standards as well as technical standards that will maximize the chance that we are going to be at scale and sustainable and will address in a positive way the various digital divides that might arise from new digital information tools. And so one program that we have done already in Tanzania that we're hoping to replicate as a model is partnership with local universities in that data feedback loop. So Resilience Academy is for Tanzanian universities, the various schools of data science, geography, geoinformatics. And they share curricula where they learn about the new different approaches, but they have an industrial placement where hundreds of students are available for mass internships. And they share the data sets that they collect, their open source GIS tools and algorithms and various image processing software together as a sort of digital good. And they collaborate internationally on research and innovation in a demand-driven way. So if anyone listening looks to sort of deploy an algorithm in Africa and they want to have local collaborators, they want to have access to very cheap, very fast sort of turnaround data collection, do look up resilienceacademy.ac.tz and reach out there or reach out to me. But I think this is a really nice way to kind of develop opportunities and make sure that data sets are as representative as possible of the target communities we want to serve. So that's the end of my slideshow, but thanks very much. Back to you, Catherine.
Great, thank you so much, Edward. That was a fascinating and really visual presentation, and really great to see the parts on the inclusion in the ML value chain at the end as well. Okay, next up is another speaker from the World Bank, Mercedes Taraverdi, who is a principal data scientist working in the US from the DC side, also on disaster risk management. So over to you, Mercedes.
Hello, everyone. Can you see my slides?
Yeah, we can see them, not in full screen mode. So yeah, that's brilliant now. Thank you.
Okay, perfect. Hello, everyone. Thank you so much. And also thanks for the organizers, such a brilliant talks. So I think quick introduction, because I saw in questions that some people ask about Edward's background. My name is Mercedes Taraverdi. I have PhD in applied math and statistics, so very quant background for international development, but my research domain has been health system resiliency. I sit in health and nutrition global engagement team in the World Bank, and my projects are on the bridging the health and nutrition and climate risks and disaster risk management. So hence the topic, it's bringing machine learning back to the ground. I mean that I picked the projects that are focusing on households and well-being of individuals with respect to climate risks. Quick definition of what I mean is like we do a lot of mathematical analysis, statistical modeling in the bank. I'm not touching them. We use a lot of cloud and server. As Edward's mentioned, these are all used ML and AI in the background. Again, like not talking about it. And, use cases of AI in climate is very broad. And this talk and the examples that I brought is focusing on machine learning for smaller data sets. So when I joined the World Bank and this domain, I realized that the opportunity is at a time was mostly on bringing different data sets together, but the size are not really comparable to private industry, right? Like we're not talking about like millions and billions of observations that get repeated like every minute, like every day. However, we do care a lot about the scalability to be able to adapt and repeat the methods and analytics for different regions and countries. Sometimes the performance is better, so we want to reduce the exclusion errors and inclusion errors sometimes, and it's easier to modify that or control that with some of the ML models, and the granularity, like the data imputation and approximations that we can use to support other teams for their ongoing economic evaluation projects or poverty focused projects. So the first example is using machine learning as part of like a project that looked into urban flood risk in Dar es Salaam. This work, it's an example that the project does not need to be defined based on ML. What we did here, like we used the household surveys that had the information on who was exposed to like recurrent flood events, and put that together with elevation and population density to come up with like an exposure to flood risk. And then this set of information was used in a larger body of research that draw conclusions on interplay of poverty and the resiliency to floods. I think this is a good example because a lot of the work that we can do and is through such support for already defined research projects or like ongoing like works in support of policy making and interventions on a country level. One other example of this is that I did the work on health system resiliency to natural hazards and pandemics. One of the key proxies that, of course, we need is healthcare facilities capacities, and even during COVID, we could see that it's such an important piece that we don't have the information of for many developing countries. And although not the best proxy to use, for example, number of beds as the capacity, but if we do that for this particular project, I use the aerial footage of the healthcare facilities, set it up with number of beds as a proxy for capacity, and then train machine learning model as for imputing some of the lost data that we have. If we don't do this, we lose observations, or we have to drop the whole set of information about the capacity from analysis, which again is extremely important in resource allocation, specifically during and after disasters. The next example is how to incorporate climate risks in ongoing works and traditional works on health and nutrition. One of the projects that I led was on understanding the risk factors of children to be extremely malnutritioned or being stunned. And there are some very known factors that, such as the wealth and the poverty level, education of the parents. However, like putting climate risks and exposure and resiliency to extreme events have not been directly incorporated and quantified in nutrition realm, so in health and nutrition. So in this project, we aim to bring in the climate risks into the decision-making and intervention designs for nutrition interventions. So this is an ongoing work. I wish that I had some results to show on this, but again, some of these are very new, not because that we didn't have the computational capacity to do it per se, like many other machine learning works that we see outside, but it's bringing different data sets together and like using the transparency that this type of modeling bring to the table to have a conversation among different sectors. And the last one is using actually machine learning for prediction. So it's nice that Ashley gave like a full background on this. So I'm gonna like skip and save us like 5 minutes on defining the micro-targeting, why it is important to understand who are the vulnerable households. And just to set the stage for this work, my colleagues did work to understand the poverty and resiliency to floods in Accra for a 2015 series of floods. It affected about like 53,000 people. And then they ran a surveys like after 2 years to understand who was exposed, what was the vulnerability of exposed people, like how much they lost, and the socioeconomic resilience. It's what were the means that they have to cope and recover from these disasters. So in socioeconomic resilience, for example, Ashley mentioned cash transfers, like social protection interventions and instruments that exist in the country. So who had access to them, who had not. The finding of this study was that that poverty that a lot of times is described based on the annual expenditure of the households. That definition is not telling the whole story. If we look at how much the poor family has lost in relative to the expenditure, then we can see that unproportionately poor people are more vulnerable to these recurrent events. What out of this that we wanted to do on top of it to come up with interventions, we use machine learning to come up with a micro-targeting of households to characterize households that are less likely to recover after 2 years, after 2 years of flood events. And also, like, I wanted here to show that what's the added value of knowing more? What's the predictive value of knowing the information on loss, information on expenditure, and information on food security on top of mostly, traditional and mostly used census data. So again, the intervention that this decision-making supports is for micro-targeting of households. So indeed, we found that machine learning models help us to get better precision. For a decision tree model, we had like 50% more improvement. I don't want to lie that we got like 99% accuracy or like precision for the groups that recovered or not recovered. We're talking about like survey data, and everyone who works with it knows that generally like the numbers that I'm talking about is like precision about like 65, 70%. However, it's extremely important for us to reduce the exclusion error, even if it's costly to have more people wrongly receiving this aid. Also, like we went with decision tree, and as you saw, like I picked decision trees for my previous examples here. Again, it's because of ease of interpretability. It's extremely important to be able to have a conversation, have a dialogue, and have some sense of why this model is acting this way, especially when it comes to human development and health and nutrition, of course, but even for like disaster risk management topics. For example, here, if you use other AI models, we could improve the precision by like 26%. which is actually very good. However, if would have make it much harder to have a dialogue and to sit with the teams and design these policies. And also, like in all of this, we could show that knowing the piece of information, which was like a relative cost, so how much poor families lose in comparison to their expenditures, is like a key information, and definitely it justifies the cost of go out in the field and gather those data. I know I ran through my talk. I wanted to save time a bit as well, but that was it. Thank you so much.
Okay, thank you so much, Mesida. That was also a really, really great presentation, and it was really great to see how much kind of these different topics all complement each other and all similar even across organizations. So we'll now head into a Q&A session. So I'll start with one question that has been coming up in a few, which is, I think people are obviously quite inspired by these presentations and interested in how one ends up in a career in such areas. So maybe I'll throw this at maybe Edward, or I mean, all of you actually could chip in, but Edward could start on how did you end up in this field, and what can specifically, there were some asking like if you're a PhD student, or how can you kind of end up in this area?
Thanks, Catherine. Well, I mean, briefly, my background is actually I did a master's in aerospace engineering originally, but then I joined the World Bank after doing another master's in international economics and climate change policy. So I was very interested in the space of disaster risk management and, broadly speaking, climate adaptation. But because I was the engineer in the team, people kept giving me all the data projects. They go, oh, you're technical, he'll do the GIS project, he'll do the collaboration with NASA. So I ended up very sort of frequently being positioned as the technology guy or the digital guy because of my engineering background, even though we weren't really doing that much technical work. So I found the international economics to be very useful, but people would sort of trust my judgment based on the engineering. I would say that there's no specific path to data science in development. I mean, our data scientist on our team has a history background. And I think so long as you're interested in that combination of communicating statistics, working with computer programming at some level and design, and understanding sort of evidence-based arguments, you can come at it from a lot of approaches. It's a very fast-changing new field. And I think that both a sort of a policy background or a technical background can be relevant. So yeah, just sort of follow what you're passionate about. But a variety of perspectives, I think, helps. Is that helpful?
Super, yeah, that's really helpful. Maybe I'll just quickly throw that one over to Ashley and Mesida as well.
I'll jump in. Yeah, good question. And I agree with Edward completely that diversity of backgrounds is really needed in the space. I mean, I'm definitely not the machine learning expert in the room, and it's good to have someone who is trained in that and knows how to apply it to, say, climate disasters or poverty mapping. But at the same time, in order for this to work, we need economists and data scientists and climate scientists and policymakers and financing people all in the room who can co-develop these policies together, and also ultimately working very closely with the structures on the ground, whether it's local NGOs or governments. So I think probably so I'm an economist by background, and that's the interest I have coming into the space, but it feels like there's room for everyone to be involved. Yeah, and also to build up the evidence base on the research front and kind of really making a case for some of these new policy innovations. So if anyone's interested, is pursuing PhDs, or like I've just finished mine, I think there's really scope for a lot of work and evidence to be built out on this agenda.
Okay, great. Thanks, Ashley. Maybe Mesida, over to you.
Same with Edward and Ashley. I think if you're interested, just jump in. A lot of it, I think the most valuable thing in working in this area is people coming from different backgrounds and how technical people have to learn the language of different professionals and colleagues on different sectors. And I found it fascinating to sit with economists, with engineers, and and to understand the questions that are of most use to the governments and decision makers on the policy side. Fascinating. And you don't have to have fantastic writing skills, and you can be pure modeler, and or you can be like fantastic policymaker. And I think like the dialogue is there, and I pursue everyone to join. It's hard to have people to choose international development over tech, and that's the reality of it. They have a very hard time finding people who will choose this career. So I appreciate anyone, and anyone who wants to be more involved, please reach out to us as well.
Great, and I think these presentations will be shared with the emails, so feel free to reach out to the speakers, of course. The next one I'll maybe ask is another quite big picture one, which is somebody has asked, what are the gaps in the use of machine learning or AI in climate change and international organizations? So maybe I'll chuck that back to Edward. Where do you see areas where there's maybe potential where AI is not being used, or that could maybe also speak to potentially skills gaps as well as knowledge gaps?
Yeah, I think, it's a broad question. So I touched very briefly at the beginning of my talk that there's this whole spectrum of sort of digital services for climate risk management. And whilst my focus has been on risk evaluation, hazards, vulnerabilities, sort of socioeconomic activity, I think there's a huge opportunity in risk awareness, in gamification or education of climate risks, in the use of or integration with social media, these sort of positive messaging attributes. That is a sort of a different regime of AI that I think we're really just getting to grips with. We do some programs where we mine social media data to try and anticipate what are communities doing, how resilient or vulnerable are they during a shock. But I think we're not really there yet in terms of knowing how to take advantage of this data. And then the next sort of the accompanying question is also a gap in terms of what are the ethics of this? What are the standards? How do we protect people? Which I think is something that we're starting now to wake up to and try to bring together experts for these discussions. So that paper that I referenced only came out in April, Responsible Uses of AI in Disaster Risk Management. Hopefully it's the beginning of a much broader knowledge base that we start to work on as a result.
Super. Maybe over to Ashley and then Mercedes also on that one, if you have anything else you're thinking about.
I think my presentation really touched on the one that I thought was biggest in the areas that I knew, which is improving targeting and how do we draw on non-traditional rather data sources to think about where we should be allocating scarce resources, especially when you have a humanitarian crisis. Budgets are tight, so trying to identify where we need to best allocate these resources. More broadly, I think this push to use non-traditional data, so that's not household surveys, but for example, satellite imagery or mobile phone data, which is controversial because of all the privacy concerns, and there's a lot of ethical questions to be considered here. But using those to map out poverty or map out migration, there's a huge range of different themes that these data sets have been used together with machine learning to predict patterns and trying to assess how well this corresponds with what we already know. And I think this really offers an opportunity in contexts where there is limited data, so especially fragile and conflict affected areas. So I think the first step is to make a case for whether they work or not before being necessarily scaled up. But it's great to see that there's momentum on that front.
Super. Yeah. Anything, Mercedes, you wanted to add on that one?
Maybe touch on something else and respond to one of the questions in the chat. We do work very closely with a lot of big companies. Facebook for Good, Google shares some of this data with us. Amazon Web Services support us on cloud computations. They provide expertise to us, and we work with them closely. One of the main challenges that we have is privacy and also representativeness, because for a lot of the technology that already exists and has been widely used and developed for the information that we need to be able to make policies that are inclusive, that are inclusive is hard. Like, for example, Facebook users, who is poor, who is not poor, where to target something. So like there are some challenges with it, but absolutely we collaborate, we bring in a lot of those into the World Bank projects as well. Wanted to just add it.
Okay, super. Yeah, that was great, because that was the next one I was also going to ask, because that seems like quite an important one. Ashley or Edward, do you have anything to add in terms of like research collaborations and internships?
If I may, Catherine, I mean, I'll just plug the Resilience Academy again as an opportunity and I think a model to co-create. Even in a very light touch way, it can be the beginning of a much deeper engagement. So what we started with last year with the German Aerospace Agency as sort of field data collection and verification, we're now doing a data challenge early next year with 40 data scientists from Europe and 400 university students in Tanzania on the tree canopy algorithms, right? So, you know, this can evolve, and I think it's really good way to transfer skills, build awareness, and local communities can contribute context, labeling, training, and I think they can get involved in what these algorithms are being intended for, and that can really help the project as well. Also in the acceptance later on, which is also a challenge. So if anyone wants a collaboration, do reach out to Resilience Academy.
Great to hear. And yeah, probably looking forward to lots of people reaching out to you afterwards. Ashley, anything on that from the OCHA or UN side?
I think from my experience with these institutions so far, it's just been quite surprised, or pleasantly surprised, by how much collaboration there is ongoing between these international organizations, with think tanks, with NGOs, with researchers and universities. And so my sense is that there's ways to work together with these institutions in other capacities that's not necessarily directly within them. And in fact, for example, within OCHA, there is still a growing capacity in terms of building out research and actually evaluating the work that they do. So they've been working very closely with these think tanks and organizations. So sometimes a way to be exposed to them is to engage with some of these research centers, for example, or think tanks who provide some of the technical services that they need.
Okay, brilliant. So a nice kind of positive note to end on there. Great. Well, we're heading to exactly the 1 hour mark. So huge thank you again to the speakers, Ashley, Edward, and Mercedes. Fascinating insight into your work, and hopefully you've spurred lots of people to start thinking more about these questions, or at least given a little snapshot insight into what you're working on, which all seems really important. As mentioned, please feel free to reach out to the speakers with further questions. We didn't manage to get through some of the detailed ones, but that channel remains open. And otherwise, thank you so much for everybody for joining, and a pleasure to be able to hold this seminar today.
Thank you, Catherine. Thank you to all organizers.